Hey YouTube, Striker5570 here, and this is just a quick update. I'm just about to start a next little project for my printer. Right now, I broke the heating cartridge, so I'm currently waiting on a new one. And I decided while I'm waiting for that and can't print anything anyways, I'm going to fix the Z-axis wobble. This has been a problem since I built this printer. These parts over here, in like part 4 or 5, I believe, of this series, I showed how this was an issue, and it still is an issue. I can really easily move and flex the Z-axis. If I zoom out here, you can really see it. Yeah, that's just on the table here. You can really see the whole thing just kind of moves pretty easily. I mostly think that's due to the fact that these parts were printed on my old printer, and I didn't print them dense enough. So there's a lot of flex to them. See right there, that flexes quite a bit, and this part here is printed. So my solution that I'm gonna try and give a crack at is just replace this whole thing here, and with an aluminum plate that'll just go right in here and thread into the end of this extrusion. So the trick is I'm just gonna have to try and get this spacing right. And another problem that I might run into is that this end here is not square on either side. So I will have to figure out a way to cut that square. And let me show you the plates that I have over here. I have the old build plate I have on there that didn't work out simply because it was a little bent. I don't know if you can tell, but it had a slight bow in it and it was just really difficult to print on. But this is an 1/8 inch thick plate here. I also have a 1/4 inch plate, and I might use this simply because it'll be much more rigid than anything else. I also plan to use the eccentric bearings on there as well, which I bought originally when I bought the parts from Open Builds. And I was going to put them in here, but just the plastic and the torque on there, I wasn't quite sure about doing that. So since the printer's not working right now, I'm waiting on parts. Figured this would be a better time than any to just go ahead and start modifying the Z-axis. Because I can show you here some of the wobble ever since I found out what my other issues were. You can see on this part here, there's a lot of Z-axis variation here. Like the layers are stacking just fine. It's just, it's moving ever so slightly like this, up and down, up and down. So you get that wobbling motion. Like if you look at it from an angle though, it's very smooth and whatnot, but as soon as you get a light on it so where you can see some shadows, it looks kind of bad. So I want it to look good from every angle, and I'm going to go ahead and resolve this Z-axis issue. So right now you can see that the printer is all taken apart. Right now I'm working on a modification slash upgrade that I should have done months and months ago, probably when I first built this printer. The reason I have those front bars off right here, they're all over my room right now. I have printers everywhere, but those front bars are taken off right now because they were pulling the whole printer out of alignment. So these back extrusions, right now the printer is flipped around, this is the back extrusions were not parallel. So I'm not sure how well this will come across on video, but they are pretty darn parallel now. Maybe just slightly askew, but it is much better than it was before. So I think what was attributing to that was these pieces down here at the bottom on the sides are not exactly the same length, and neither are these up here, these top ones. So by putting, where's that piece actually? By putting this bracket up front and trying to pull the front pieces flush, it was actually pulling the back ones out of alignment. So what I did is I added these brackets, same ones that were up front, but I added them in the back, and I won't put them in the front. So I can still hold them together, the printer together, and keep side-to-side wobble from happening, but without pulling the z-axis out of alignment. Now, the whole reason that the z-axis needs to be in alignment, and this is so critical, is that this extrusion here is what your z-axis rides on. It's what it slides on, which leads me to my next upgrade that I'm doing. Here we have the these are the 20 by 60 millimeter extrusion slider pieces. At least part of them. There's the other piece that goes on the other side that retains the wheels. But you can kind of hear this isn't a very strong part. I printed this on my old 2-up, and it really wasn't extruding very well on infill. I'm not exactly sure what the problem was. But this part, you can see, can flex, and you can hear some cracking too. I don't know if I can get the light to reflect off here. You can see where the screws are. They've deformed the part, which means it wasn't actually able to get tight ever on the extrusion. Also, you can see here on the little ramped part, this screw just bit right into it. It didn't even lock in properly. So that was causing these pieces to never really fully lock in here, and the bed was just really wobbly. And as a result, every time you'd move up a layer, the bed would move unevenly. And I am getting, since I fixed my blobbing issues, this issue became much more apparent. So you can see the print looks fine from like this angle, but you catch the light coming from the ceiling, and you really see all those layers, how they're slightly misaligned. And it's like it's a rhythmic sort of thing. So what I'm feeling is, or thinking is, so the bed will be pushed up a little, and then like it would sort of level out, pushed up. It was sort of doing this sort of motion, or actually reverse. Since it would be moving down, not up. But like as it's printing over that layer, it's sort of pushing down the bed on here because this isn't locked in. It's able to move freely, and it shouldn't. So finally, getting to my point here, I've been making some brackets out of the old aluminum bed, and I am going to show you how I'm going to do that. So if I can get the light here to focus right. It's pretty simple, and I have made dimensions, and I can post those in the comment section, or the description, apologies. But these utilize the Open Build's eccentric bearings. So they're eccentric spacers, whatever they are, and that ensures that this will lock on nice and tight to the extrusion, and no back and forth wobble whatsoever. So I'll show you how I make the second one. I'm going to cut it out of this section right here, and just using a drill press and some calipers and a center punch. It's very simple, and I will show you how to make it pretty precise. No need for a milling machine or anything like that. Alright, so you will need some blueprints, and just working through some of the math of the wheels here, I came up with these numbers, and after a little bit of trial and error, I came up with this one, and this has a very nice tight fit, but it's a little tight, which is good. But the eccentrics are the biggest they go. So I'm adding 0.5 millimeter to this dimension here, making it 15.5 millimeters, which I've already marked on here with the calipers, so you can see where I've scribed. Then I put dots and Sharpie where I need to drill. But before you drill, you need to get a punch like that, and you will just hammer all these holes so that way you can have a guide. And one thing you need to be aware of when drilling, especially through aluminum, is aluminum is very soft, so you're going to want to start with a smaller drill bit. So I just pretty much work my way up bit by bit in this, even though this is only like 1/8 inch thick. Even on a drill press, since I don't have any sort of vise or anything like that, and I'm working with this whole big sheet, it can easily get sucked up out of your hands, and the drill bit can really bite into it. So you need to work your way up with the drill bits. If you look over here, you can see a poor example where I did not work my way up with drill bits. And not only did it grab the aluminum, but it created holes that were not perfectly round. You can clearly see this hole is not perfectly round, and it did cause problems for fitting the eccentrics. And this was the test run, and I messed up the dimensions anyways. But so third time's a charm. So this one, last one here, should be perfect. So let's give it a go. Alright guys, we're over here at the drill press, and I just wanted to show you that I have drilled the pilot holes here with a few sizes smaller hole. We're again drilling for an M5 screw, and also I'll remind you that you will have to tap the end of the extrusion. I do have a video on how I do tap those extrusions. I uploaded a few months ago as part of the series. So I will, you can go to my channel and see the whole playlist of these 3D printer series videos, and I have a video on how to tap those extrusions. So anyways, I just want to show you that I will be drilling a hole. See, that is a little smaller than 5, so 4.8 around there. And 4.9 at the very top. You can see the top part here. It's a little thicker. So we'll be using I believe this is, I'm not sure, but this drill bit measures 4.84, so just 4 thou bigger. I'm doing everything in metric. I don't have a metric set. Not exactly sure what size this is, but yeah, we're going to go ahead and drill these holes, and then we'll drill the other two for the eccentrics. Alright, now the eccentrics here measure 7.11 at the end right there. So that will use okay, so the only one I have here is a 9/32 bit, which measures 703. So we're 1/8 thou too small. So that's quite a press fit, but I found I can sand it out. I don't have a reamer or anything like that, but it'll be good enough for our purposes. So I'll go ahead and put this bit here. Alright, there you have it. There's the holes for the eccentrics, all the holes for the M5 screws. Now what I'm going to do real quick is grab a deburring tool. One of these little rotary things they're really great for deburring these. You pretty much just stick them in the hole right there. And you push them around. And now you have a nice little chamfer on the edge right there. So you just do that through all the holes, both front and back, clean it off, and yeah, should be good. Alright, I have assembled all the hardware, and by the way, this is the same exact hardware that is used in the 3D printed parts, except I'm using Open Build's 40mm screws here. I had accidentally bought these, and now they're coming in handy. So 40mm ones. I am gonna have to come down though. So, but the low profile screw heads, if those will focus on here for me, I guess not. They do look really clean from the outside. There you go. You can sort of see them. And with this adjusted, the eccentrics are all adjusted and snug. This is no wobble in it, like no play at all. Like you can't hear anything. So it's looking good. So next step is to cut out these two brackets and put them on the end of the 60 by 20. Alright guys, we're back, and I have cut out the two brackets, and I just finished sanding them down on the belt sander, and sanding off the edges, making them nice and soft, so no super sharp edges on here, with 150 grit sandpaper. And right now they're ready to go. The holes between the two aren't quite lined up, as I just held them together. I'm not exactly sure what happened, but you can't. The holes right there are a little off, but they'll be shifted about 2 or so millimeters. But these will be, you know, they're going to be 450 millimeters away. That's not going to matter too much. All that matters is that these holes here are all properly spaced, which they are, and that these holes are properly spaced. So cutting them out, it really doesn't matter, because all the holes are referenced off of these center holes. So as long as those are all lined up, should work. So let's put it together. Alright, I have the Z gantry all on here. I don't have the lead screws hooked up just yet. I just wanted to see how smooth this was. It is a bit tight. Like I said, the first one I made was a little bit tight, maybe a little too tight. It's I don't know if you can tell, but it's bowing the plate ever so slightly, but it is rock solid. This thing is, it's free falling, so it's not that tight. So that's all it needed to be. But you can see it does have a little bit of lag. But once I have the bed and the plate on there, should be pushing it down a lot easier. I also did gain a teeny bit more Z travel with this. Since these plates are a little more low profile, they don't hit the end block there. So the drag cable actually is the limiting factor now. So it doesn't even hit there. The drag cable is the limiting factor. So, anyways, I'm going to. Also, I had to add washers here. So you can see that. There you go. Yeah, I had to put washers here and then over there also, because this bar was cut to length for the printed parts, and So these are a lot thinner, of course, so it's not the same. So I added 5 1mm washers right here, so 5mm, just to get it to the right length. So on this one there aren't. On this one there are. That was just to get it to the right length and everything. So this is all good and well, and the good thing about having this so solid is this will force these pieces square. So I don't know how well you can tell. If I can just get the edge, they are extremely square right now, like I showed you at the beginning of the video. And this should work pretty well. I'm really excited to see what improvements the Z-axis will get. And I am back, and not actually in my room at school. I am back at home for winter break. And the first thing you might notice here in this update is I got some LED lights. I actually got these LED lights for Christmas, and I wired them up to the power supply, and they're pretty cool because they change colors, whatnot, with this remote. I also change it. That kind of hurts, but I mostly just keep it on the white one for a white light for printing purposes. But it's pretty cool. Now it's not just a printer, it's kind of like a cool lamp, I guess. So it'll be pretty cool once I get back to my apartment at school. So anyways, a few things here. First of which is I remade the brackets in the back, and they are made out of 1/8 inch aluminum plate, 6061 plate that I originally had for the bed, and I will try and see if I can put the dimensions up for those plates. One of them is a bit tight, but it still works, and this plate here was just right. So they utilize the eccentric bearings. It's kind of hard, the light's not that great in my room, but you can see the eccentric bearing here, and then a few washers I placed on the other side, because the length of this bar here was originally for the PLA sliders. So it's working pretty well, actually. This is my second print on it. I don't know if you guys remember from my last video, I was printing these shotgun pieces out. These just hold 2 shotgun shells, so you can load 2 at a time. And they turned out alright since I had fixed my blobbing issue. And maybe if I come over in this light here, yeah, you can see the ridges right there from the Z-axis wobbling a little bit. And it's really, you don't really notice it from this angle, but as soon as I turn it into the light and you get cast a shadow on it, focus on here, you can really see it. So, and plus I had a bunch of like retraction and perimeter crossing issues here, which I have since resolved. So here you can see this print is see if I can get the focus on here real quick. There you go. This print is looking exceptionally smooth. I'll give you a shot of it once it's completely done. I can show you it in the other light too. But it's coming along really well. These aluminum brackets back here were definite upgrade. They have really improved the quality overall. So yeah, that's pretty much the 2 biggest things. Also, I replaced the thermistor and heating cartridge because I accidentally broke those when I was fixing the jam. So I had to replace those. So that's why it's kind of been a while since I've been able to make an update video. Things were really slow with shipping with the holidays and everything. So yeah, everything is, the next step is just to get everything in one contained unit, and this printer will pretty much be done. Alright, here we are with the print straight off the bed, no cleanup or anything. I probably still need to do a few things with traction. There's a little bit of stringing, but it is much less than it was here. This is the other part, was cleaned up with a knife, but I'll tell you it was a lot worse, and it still is a lot worse than this, and this is straight off the printer. So I'm just going to compare them in the light real quick. So from here, you can see the lines a little more on this one than on the more recent one. Now if I stand them on end, I can show you. If I do them back to back, a little easier. Find the right focus point, but this one that still has the brim on it is the new print with the new Z-axis, and then the one is the old one. You can see here's the old one here. Like you can see the ridges on there, and here is the new one with the new Z-axis. Focus. There we go. You're of course going to get a little bit of ridges just from the layers, but it is far less profound than before. And just by feeling, just by touching these parts, this one is a lot smoother, a lot nicer to touch. Just a few overhang issues. I think I was printing a little warm. Like I said, I did get a new thermistor and heating cartridge, so I will have to adjust those settings accordingly. But overall, this is a very good improvement over the previous Z-axis. So, alright, thanks for watching. If you have any questions or comments, leave them below. Thanks.